All right, if you're tackling the CCSP, you know that Domain 1 is everything. It's the foundation for all the other domains. So today, we are going to lay down the essential blueprint. We're going to get you fluent in the language of cloud security, and we're starting right now. So, let's just jump in with the biggest question of them all. We throw the term the cloud around constantly, right? But if you had to pin down a super precise definition, well, it's actually kind of tough. You've definitely heard this saying before. And, it's not wrong. It does capture a piece of the puzzle, especially for public cloud, where you're renting space on some giant provider's hardware. But it's a massive oversimplification. It's a catchy line, but it completely misses the mark on things like private clouds. And more importantly, it doesn't tell you what actually makes the cloud the cloud. So let's get past the slogan and build out the real blueprint.
Here's our game plan. First, we're going to break down what the cloud even is. Then, we'll nail down the golden rule of accountability. After that, we'll check out the different services on the menu, figure out where it all lives, and wrap it all up with the security playbook for managing risk.
So forget a dry textbook definition. The best way, the NIST way, to define cloud computing is by its 5 essential characteristics. If a service checks these 5 boxes, then, yep, you can call it cloud.
Okay, first up, on-demand self-service. That means you, the consumer, can get resources like a server or storage without having to talk to a human or file a ticket. You get to it through broad network access, which just means you can use it from your phone, your tablet, your laptop, whatever. The magic behind this is resource pooling. The provider has this massive pool of resources that it shares out to lots of customers. This pooling allows for rapid elasticity, which is the ability to scale up your resources almost instantly for a big traffic spike and then scale right back down when it's over. And finally, it's a measured service. You pay for what you use, kind of like your electric bill.
Now, the secret sauce that makes the economics of public cloud work is multi-tenancy. This is where multiple customers or tenants are sharing the same physical hardware, all while being logically separated from each other. That's how providers get those massive economies of scale. But, and this is a key point, it's not a universal characteristic of all cloud, because a private cloud is for just one organization. It's single-tenant by design. All right, this brings us to what is without a doubt one of the most critical concepts for your CSSP exam and just for cloud security in general. When something goes wrong, who is ultimately on the hook?
You have got to know the difference between these two words. They're not the same thing. Responsibility is about doing the task. It's the how. You can absolutely delegate the responsibility of, say, patching a server to your cloud provider. But accountability, that's about ultimate ownership. It's the why. It's the final buck stops here. And here's the kicker. It can never be delegated.
Let this sink in, because it's the golden rule. Your organization, as the cloud customer, is always, always, always accountable for your data. End of story. So if there's a data breach, yeah, the provider might be held responsible for failing to secure a server, but your company is the one that's accountable to your customers and to the regulators. And to really get this, you got to know the players on the field. You're the cloud consumer. The company you buy from, like AWS or Azure, is the cloud provider. Sometimes you'll have a cloud broker in the middle, kind of like a consultant. And on your team, you have the cloud administrator running the show day-to-day and the cloud developer building the cool stuff. Knowing who's who is step 1 to understanding who's accountable for what. Okay, let's talk about how these services are actually sold. Just think of it like a restaurant menu with 3 main choices: infrastructure, platform, and software as a service. Each one gives you a different level of control and, more importantly for us, a different division of security responsibilities. And that brings us to the shared responsibility model. This is a huge concept for the exam, so really pay attention here. With IaaS, or infrastructure as a service, the provider gives you the raw computing power, but you're responsible for everything from the operating system on up. Move to PaaS, platform as a service, and the provider handles the OS and middleware for you. You just worry about your application and your data. And then there's SaaS, software as a service, where the provider manages almost everything. Your main job is controlling who has access and protecting your data. And notice that bottom row, data and access, is always your job as the customer.
Okay, so we've covered the what and the how, but what about the where? That's where cloud deployment models come in. They basically answer two simple questions. Who owns the hardware and who gets to use it?
You've got the public cloud, that's the one we all know, run by a provider and open to everyone. Then there's private cloud, built exclusively for one single organization for maximum control. A community cloud is a variation of private, where several organizations with a common mission, like maybe a group of government agencies, share the cost. Now, don't get these next two mixed up. Hybrid is when you connect a private cloud and a public cloud together. Multi-cloud is different. That's when you're using services from more than one public provider, like using some stuff from AWS and some from Azure.
All right, let's get strategic. With all these moving parts, you can't just wing it. You need a playbook. This is where we talk about the structured, repeatable ways you can manage security and risk in the cloud.
Think of this as your look before you leap checklist. These are the hard questions you have to ask before you sign on the dotted line. Cloud providers make it super easy to move your data in, but what about getting it out? You have to think about portability and reversibility from day one. Getting locked into a vendor isn't just an IT headache, it's a massive business risk that can cost you a ton of money down the road. Now, the good news is you don't have to invent a security program from scratch. There are proven frameworks that give you a blueprint. ISO 27001 is your high-level guide for a whole security management system. The CSA-CCM is a super practical spreadsheet of controls specifically for cloud environments. The NIST RMF is a very detailed step-by-step risk process, huge in the government space. And FIPS 140-3 is the gold standard you look for to make sure any cryptography in use is properly built and validated.
So when you're looking at risks, you've basically got two ways to analyze them. Quantitative is the dream, right? You assign an exact dollar value to risk. It's powerful if you can do it, but honestly, it's often really hard to get accurate numbers. That's why, in the real world, most of us use qualitative analysis. We assign a relative rank, high, medium, or low. It's based on expert judgment, it's way more feasible, and it's perfect for prioritizing what to fix first.
Once you know what your risks are, you have four main moves. You can avoid it by just not doing the risky thing. You can transfer the financial impact, usually by buying insurance, but say it with me, you can never transfer accountability. The most common one is to mitigate the risk by putting security controls in place. Or, finally, you can formally accept the risk. But that's a big decision that has to be made and documented by the accountable asset owner. And when you decide to mitigate, you've got a whole toolkit of controls to choose from. You need to know how they're categorized. By implementation, is it an administrative control, like a policy, a technical one, like a firewall, or a physical one, like a fence? You can also group them by function. Do they try to prevent an incident, or do they detect it and help you correct it after the fact? Building a strong defense means using a healthy mix of all these different types of controls. So, getting a solid grip on these fundamentals, the service models, deployment models, shared responsibility, and risk management, this is the absolute price of admission. It's the groundwork. But it all leads us to this final critical question. The cloud changes every single day. So how do we build security that is tough enough to handle serious risks, but also agile enough to not get left behind? Answering that, well, that's the real ongoing challenge for every single one of us.